next part of the sprint video will be about showing the brief demo and how this application works. And so this is the main script. If I run this main script, it will take some time to load the model so that it gets ready to run the user features. And these are the 7 features we have right now. And so what if I want to load a document? So as of now, I haven't loaded any documents in the model. The way we can verify that is if we go under the generated folder, there are no files under this generated directory. And so which means that the model currently has no data. And which document um, I want to load to the model, then we can go inside the input folder. And let's say I want to unload pilot operating manual document. And I can just copy and paste the name of the document. And so hit enter. So now, not only we're just unloading the document to the model, it will automatically parse the page by page, and within each page, it will further parse sentence by sentence and then put that parsed data into a well-structured JSON data. And subsequently, all of the embeddings will be generated based on the parsed data. So this is, you can see here, we have 4 types of data, and this is the parsed data without the embeddings, and this is the one with the sentence embeddings. And not only that, we also um, want to make sure to have a parse data term by term based on the terms so that that can be used for graph search algorithm, and which we can see in here. So this is the terms, and where is that? Yeah, so if we go to the last JSON file, we can see the terms embeddings in here. And now these data are loaded to the model. Now, what if I want to unload those data? Maybe because we don't want the model to have this data, or maybe the model is overloaded with so much of data that we want to get rid of some of them. And we can go to the feature number 2. So this is the list of the unloaded documents, and it makes sense because I've loaded so far only the pilot operating manual document to the model. And so if I wanted to copy and paste this, and now, as you can see, um, all the JSON files under the generated folder now disappear because I unloaded the documents. And also, there is another cool feature that I want to show you, which is I'm going to quickly reload the same document. And so I quickly reloaded the same document. And let's say, so you may want to ask yourself, do I need to reload the same document every time I start the program over? And let's see. So I'm going to quit this program real quick, leaving the JSON files under the generated folder. And I want to restart the program. And every time I restart the program, it will check to see if there are any pre-existing files that under the generated folder. If there are some, it will make sure to upload them to the model automatically, as you can see here. So pre-existing document data has been loaded to the model successfully, which means that we don't need to reload the same document over and over every time we quit the program and start it over, which I think is a cool feature for the model to have for great convenience. And Now let's go to the search feature. So number three, and the current list of loaded documents. Which document would you like for the model to run? The first document that we loaded. So let's see. So it will take some time to get the model for the model to be ready. And once it's ready, it will ask you to type a user query. So let's just say, what is auto throttle? Maybe. Yeah. So this is the this is the result from user query auto throttle, and then like so far my direct lookup feature doesn't consider um it has to be the exact same match form. So if I don't include a white space, it won't be able to find it and then spit it out for you. That's another thing I might need to work on in the future sprint if time is permitting. And so the second search kind of feature that I want to show you is the beautiful soup. As I showed in the last sprint video, it will fetch the definitions from Wikipedia just in case some of the terms from the loaded documents are not outdated. So this is the exact definition that my model was program was able to fetch from the Wikipedia page. And then the graph has been saved to, so now we can also see the graph, how the graph looks like, and so that it will, just in case if there are any adjacent terms or concepts related to auto throttle. But since I didn't include the white space here, it won't tell you any terms that are related. And and you can also check the how the graph looks like, obviously. So this is how our current graph looks like. And after the search feature is ran, it will ask you if you want to continue the search feature. So let's say yes, and this time let's just put the um, with the white space. And now, as you can see, since I included the white space, get all some it will get the exact same information relevant to the user query. So these are all the information directly from the unloaded documents, and you can see some of the metadata such as page number and where you can which sentence. So sentence index 6. So this is the actual text regarding the auto throttle. And now these are some of the terms related to the auto throttle that I entered, and then the term extracted was auto. So this is the list of terms that are related to auto throttle, and, yeah, and then also you can see that the graph has been updated as well. And for the web scraping, so the output from the web scraping is empty, so that's why it's not printing anything. So it's kind of like dependent currently, like how you format the terms or how you format your user query, I would say. And let's just keep going. And this time, let's just say what is landing gear, and this is all the text related to the landing gear and the term extracted gear, and this is the Wikipedia definitions, I'll say, from the landing gear. And since the term extracted is gear, it will also tell you some of the terms that are related to the landing gear. And we've got one result, which is gear lever. So we can say that gear lever is conceptually related with gear. Now I want to show you the translate documents, and so it works the same. And so which language would you like to translate, since following documents are written in English? So I'll just say English. and translating into Korean. Let's just say, for example, and choose a starting page to process. So starting page number, let's say page 5. I want to translate through page 5 to page 7, for instance. So this tells you the total number of sentences that need to be translated from English to Korean. And since for translation feature, I had to use a pre-trained model, if your laptop only has CPU, it will take some time. So now it will print uh, the translated documents by batch so that by the time the users finish reading the first batch, it will hopefully, yeah, it should be enough time for the model to process and give you another second batch of responses. Yeah, since this is a pre-trained model, Hugging Face, I can't say this is highly accurate, but especially if the sentence is complex, complicated, it tends to uh, be prone to more errors. But it was the one of the best one that I could find among the free open sources. Yeah, free open source pre-trained models. I mean, so the model is giving out third batch of responses. So by the time the users finish reading the third batch of responses, then the model should have enough time to process it and give you another batch of responses until it's done its job translating through page 5 to 7. So now it's done translating, and yeah, so you can see some of the words that are being repetitively used, and some of the words are not completely irrelevant to the actual text. And these tend to be quite noticeable, especially if there are some actual text that which form is out of the norm. And so please, and then yeah, please type 1 to continue or 0 to quit. I want to quit and then go back to our main menu. The last feature that I want to show you is to summarize the documents. And this should take really fast because I'm not relying on pre-trained model to summarize since this is a extractive summary based on the embeddings. So this is the model and I want to run the document I want the model to run, choosing a starting page, the same page number, let's just say 7, and enter a max summary sentences. Let's just do 20 sentences. And now this is the summary result using the extractive summary method. Yeah, so far these are all the features that I've been working on in the Sprint 7, and this was the demo. Yeah, so thank you.